Create the following based upon a given data set and given parameters: frequency distribution table, frequency histogram, frequency polygon, and ogive. Using the data set entitled President's Age at Time of Inauguration, create a frequency distribution table using 5 classes, including columns for class limits, both lower and upper, class boundaries, both lower and upper, frequency, class midpoint, relative frequency, and cumulative frequency using Excel. Then, using Excel in the frequency distribution table, create a frequency histogram, frequency polygon, and an ogive. After completing the 3 graphs, determine if there are any outliers and discuss what that might mean. Alright, the first thing that we want to do is actually look at the list of presidents and their ages at inauguration. There were 45 presidents. Actually, only 44 people have held the office of president, because Grover Cleveland was the 22nd and 24th president, respectively, with Benjamin Harrison being in the middle as the 23rd president. Regardless, what we want to do is go ahead and use Excel to help us begin this process and to help us finish the process. So what I've done is I've gone ahead and copied the table into Excel. You'll notice that I've got the presidents listed chronologically and in their ages at inauguration. So what I want to do is use the power of Excel to help me organize this. So what we're going to do is we're going to start by highlighting the column of the ages at inauguration, and then we're going to left click sort and filter, and then we want to left click sort smallest to largest. It will give us a sort warning where it says Microsoft Excel found data next to your selection. In this particular case, I want to include the data next to my selection, which would be the names of the presidents, because I want those names to sort along with the ages at inauguration. So I will left click sort once I make sure this radio button is pushed, and you'll note that not only have the ages at inauguration been sorted numerically, but the names associated with those ages at inauguration have also been sorted. So now what we want to do is we want to be able to go ahead and begin the process of creating our distribution. And you'll notice that the minimum age here was 42 and the maximum age here is 70. So the first thing that we need to do is go ahead and find the range. Now, I'm going to do that manually first. And we'll start by going ahead and saying, all right, the range is simply going to be equal to 70 minus 42, which in this case is going to be 28. Now remember, the number of classes is going to be equal to 5. So to find the class width, I simply divide the range by the number of classes that I want to use. And that gives me 5.6. Now remember, you will always round up to the next convenient integer. Even if this had been 4.1, I would have rounded up. So we're going to use 6 as the class width. Now remember that I said use the next convenient integer, because sometimes that's not going to cover all of the data values. Remember, the data values here range from 42 at a minimum up to 70. Now what I want to do is understand, will this 6 class width cover all of these data values? Now, to ensure that I've got the correct class width, what I want to do is I'm going to take 42 and I'm going to add to that the number of classes that I'm using times the class width, and I'm going to subtract 1. That's actually going to give me my upper limit of my last class, and so that's going to be 42 plus 30 minus 1, which is equal to 71. This value right here is definitely greater than the largest value in my data set, so using 6 as the class width is going to work nicely. So then the next thing that we're going to do is go ahead and determine what our class limits are. And so we'll start by creating our table and saying, okay, here's our class. And then we're going to have our lower limit column and our upper limit column. The lower limit of your first class is always your minimum value. Then what you're going to do is you're going to add the class width to that, which in this case is 6, to get the lower limit of the next class, which in this case is going to be 48. Now there's two schools of thought on this. I can either go ahead and say, well, if the class width is 6, I can then take this new lower limit and subtract 1 from that to get my next upper limit of the first class, which is 47. Or I can simply say if my class width is 6 and I subtract 1, that's 5, and I add that to each of my lower limits, I will then get my next upper limit. And you'll see that that does work going from 42 to 47. But I'm going to use the traditional method here. We're going to take the lower limit of the first class, add 6 to it to get the lower limit of the second class, and then subtract 1 to get the 47. Then it's a matter of just adding the class width to each of these new limits. So I can add 6 to this one, and I'll have 53. I can add 6 to 48, and I'll end up with 54. Then the next one will be 60, and then the next one will be 66. And you'll notice that this gives me my 5 classes. So I'm just going to number them: class 1, class 2, class 3, class 4, and class 5. And then I'm going to continue the process by adding 6 to each of the upper limits, and I will end up with 59, 65, and then 71. The next thing I want to do are the boundaries. And we're going to have a lower limit for the boundaries, and we'll have an upper limit for the boundaries. Now, the lower limit is going to be 0.5 subtracted from your class value. So here's my lower limit for my first class of 42. I'm going to subtract 0.5 from that, 42 minus 0.5, and that will give me 41.5. I'm going to do the same thing for my upper limit. I'm going to add 0.5 to 47 because it's going to be on the other side. So we'll write 47 plus 0.5, and that will be 47.5 for my upper class boundary. And then what I want to do is go ahead and just simply add 6 to each one of these to get all of my boundaries. If I add 6 to this, I end up with 47.5. You'll notice that that is 0.5 less than 48. I'm going to add 6 right here, and I end up with 53.5. And I'm going to continue to do that, and this is what I will end up with. You'll also notice that as I'm writing this out, that the upper boundary of the preceding class will be equal to the lower boundary of the next class. And so I can continue to just add 6 to these, and I can double check to make sure I'm adding correctly. And I note that the 53.5 right here matches the 53.5 right there. So now I'm going to erase all of these hash marks to try to just tidy things up a little bit. And I'm going to finish my boundaries, and I'll have 65.5 here, and then I'll have 71.5 right here. Now, I'm going to go ahead and delineate these. And so I've got the beginnings of my frequency distribution table here. The next thing that we want to add in will be the midpoint column. And the midpoint is simply going to be taking your lower limit of your class and adding the upper limit of the class and dividing by 2. So that would be 42 plus 47 divided by 2, which is going to give me 44.5. I don't have to do that for the rest of them because all I have to do is take the class width and add to each preceding midpoint. So this is going to give me 50.5. This will be 56.5, 62.5, and then 68.5. Once again, let me tidy this up a little bit. And now we can move on to our next column. Our next column is simply going to be the frequency column. And that's going to give me how many values in the data set fall into each of the classes. So the first one is from 42 to 47. So what I need to do is actually look at my data set, and I need to look for those values that are from 42 to 47. I'm going to bring the Excel slide back in, and I'm just simply going to highlight this from 42 to 47, and I note that there are 6 values there. So I'm going to go ahead and write that in my distribution. Okay? 6 values. Then I'm going to look at the next one, which is going to be 48 to 53, and I'm going to use the distribution again. And so I highlight from 48 all the way down to any values that are 53 or less. This case, it's going to stop at 52. I'll add those together, and I see that there are 11 values here. And now I need to look for the values that are between 54 and 59. So once again, we'll bring in the Excel slide, and we start here at 54. And we're going to look for all values that are between 54 and 59. And then when we go ahead and count that, we see that there are 17 values there. So we'll go ahead and write that here. And then the next one is going to be between 60 and 65. So once again, I'm going to go back to my Excel slide, and I'm going to go from 60 to 65. And when I count those up, I'll see that there are 8 values there. And then finally, from 66 to 71, we'll go ahead and we'll look at the distribution, and we'll see that there are 3 values that fall within that range. Now, one of the things that I want to do here is go ahead and add the values in the frequency column. If I add these values up, and they become and it adds up to less than the total number of data values that I have in my distribution, then I know that I've done something incorrectly. I missed a value somewhere. But if I go ahead and sum the frequencies, and I'm going to use the Greek letter sigma for summation, and I'm going to use an F, I see that I end up with 45. The next column that I want to do is going to be the relative frequency column. The relative frequency column is simply going to be where I take the frequency of each class and I divide that by the total number of data values. So this one would be 6 divided by 45. And I'm going to go ahead and round this to 2 values here, and I'll end up with 0.13. And I'm going to do that for each one of these. 11 over 45, that's going to be equal to 0.24. And then we'll have 17 over 45. That will be equal to 0.38. And then we will have 8 over 45, and that will be equal to 0.18. And then we'll have 3 over 45, which will be equal to 0.07. Once again, I want to add these values, and I'm going to call that the summation of the frequency over n, or the number of data values. This value should total 1 once you add this up, but because of round-off error, it may be just under 1 or just above 1. In this case, it is equal to 1. The last column that we're going to create in our frequency distribution is going to be the cumulative frequency column. And that's simply where I start with the first frequency, which in this case, once again, is 6. And then I'm going to add the next frequency to it, which in this case will be 11. And I'll get 17. Then I'll add 17 to that to get 34 because 17 is my next frequency. And then I will add 8 to that to get 42. And then I will add 3 to that to get 45. Here again is another check. This should be equal to the total number of data values that I have in my distribution. That's how you create a frequency distribution table by hand. My next video will show you how to create this in Excel.